Alright, so now we're looking at this problem over here, and we're given JL, line segment JL congruent to KM, JL congruent to KM, okay? And we're trying to prove JK congruent to LM. So we start, number one, by writing our T-chart, statements and reasons, number our rows. We write the given JL congruent to KM, and our reason is going to be given. Okay, so what's our first step to completing this proof? Turn any given congruency statements into equations using def of congruent statements. So I have a congruency statements right here. I'm turning him into equation. So it's JL is equal to KM. Notice that the lines over JL and KM go away because we're talking about the measures now. And my reason here is going to be def of congruence, which lets us go from congruency statement to equation, and equation back to congruency statement. Okay, so what's our next step? Next step is any midpoints given, then we use definition of midpoint to turn those into equations. But we are not given any midpoints. Right here, are we given any midpoints? No, we're not given any midpoints, so we skip that step. Next, we go ahead and look at the figure and say, are we given 3 points on a line? Because if we're given 3 points on a line, now we use seg-adpos to create an equation. First part of the segment plus second part of the segment equals the whole segment. Okay, and so we look at our figure. Right here, are we given 3 points on a line? Yes, we're not only are we given 3 points on a line, but we're given 4 points on a line. Okay, so how do we deal with 4 points on a line? If we're given 3 points on a line, it's AB plus BC equals AC, the whole thing. First part plus the second part equals the whole part. Seg-adpos. Okay, we're given 4 points on a line. What do? Well, you take the first 3 points, those 3 points on the left side, and you use seg-adpos on those 3 points, namely JK plus KL equals JL. First part plus the second part equals the whole part. Then you look at the second 3 points, and you do the same thing with seg-adpos. First part plus the second part equals the whole part. So that's what we're going to do. We're going to create 2 equations using seg-adpos. It's going to be JK plus KL is equal to JL. Second equation, KL plus LM is equal to KM. And this is seg-adpos. Okay, so now we're done. We've used seg-adpos to create our equations. Last step is substitution to get to the proof statement. So how do we do this? Well, we have 3 equations. We have 1, 2, and 3 equations, right? So what can I do? Well, I can take this, what can I do? Oh, okay. So notice here that this left side, it means anywhere I see JL, I could put this expression. Right? Do I see JL anywhere in any of the other equations? Do I see JL over here in this equation? No, I don't. Do I see JL over here in this equation? Yes, I do. It's right there. I want to put this expression in the place of JL right there. Okay. Now, I look at this one right here. I look at this expression. What does this equation mean? It means anywhere I see KM, I could put this expression. Right? And do I see KM here? No. Do I see KM up here? Yes, I do. So I'm going to take that expression. I'm going to put it right there. Substitution. So let's go ahead and substitute. We got JK plus KL is equal to KL plus LM. 4 is substitution. Okay, great. Now, what do we want? We want JK equals LM. We want JK equal LM. We want the KLs to go away. Can we make the KLs go away? Yes. Subtraction. It's the same value on both sides of the equal sign. So I'm going to subtract. So I'm going to do JK plus KL minus KL is equal to KL minus KL plus LM. That's subtraction property. Right? What am I doing here? I'm subtracting KL from both sides of the equal sign. I'm subtracting the same number from both sides of the equal sign. Subtraction property. So now 6, those KLs are going to go away, be replaced with 0. Right? So now it's going to be JK is equal to LM. The KLs get replaced with 0, what they're equal to, and that is substitution. Now we don't want it to be equal sign, we want it to be congruent, because that's what the proof is. So I'm going to say step 7 is line segment JK congruent to line segment LM. 7 is def of congruence. Like so. Okay. Def of congruence lets you go from equals to congruency sign, or congruency sign back to equals. Right? We did congruency to equals, def of congruence. We did equals to congruency, that's def of congruence. And we are now done.